In the good old days, when it comes to WoL or WakeOnLan, it's pretty straightforward. So you have a machine, it's in sleep mode, but its network card is still consuming a little bit power, listening for a specific type of network packet, so-called magic packet. If you want to connect to the sleeping machine, you can simply send out the magic packet, then the machine will wake up. Okay, but in modern days, for Windows and for Mac OS, WoL is becoming more and more complicated in different ways. In my channel, you can find two videos, one about WoL in general, the other one about Windows. So this video is about Apple Mac OS and about the Bonjour service called Sleep Proxy. In fact, Apple Bonjour service is a special implementation of MDNS. If you are interested, you can take a look at the MDNS video in my channel. In this video, we are going to explore 4 different scenarios. First, a very old Mac machine together with a Apple TV. The second scenario, what if we don't have Apple TV? Will the iMac still wake up from sleep? The third scenario, let's use a pretty recent Mac machine. And the last scenario, let's examine whether Apple TV is really necessary or not for a new Mac. This is my lab environment. In the lower left, you can see a 15 years old iMac, and in the lower right is a Linux machine. I'm going to use it to try to wake up the iMac. From the diagram, you can see I also run 2 Wireshark sessions in parallel so that I can capture the frames for the Apple TV and the iMac, and then later we can look into the details to understand how the sleep proxy and WakeOnLan works for this iMac. By the way, if you are familiar with unified switches, you may know for one switch on the UI, you are only able to configure 1 pair of monitoring ports. As you can see here, I have 2 pairs of monitorings, right? If you are interested, you may check another video in my channel. Apple's Bonjour is a implementation of so-called zero configuration networking. It uses MDNS. In the right side, you can see the Bonjour Sleep Proxy. It's just one of the services supported by Bonjour, and it's a component of the zero configuration networking. If you are interested, take a look at these 2 Wikipedia articles. This is my lab environment. As you can see, I use unified devices. All the computers in this video are connected to the same unified switch. In the first scenario, I will use a 15 years old iMac in the lower left side, and in the lower right you can see the Linux machine. I will use it to try to access a sleeping iMac to see whether or how the iMac will be waked up. I choose a Linux machine instead of a Apple machine on purpose because I want to show you the sleep proxy works not only for Apple client but also for any computers. During the testing, I'm going to run 2 Wireshark sessions. The first one will be monitoring the Apple TV. The lower one will be monitoring the iMac. On the switch, I already configured port mirroring. Okay, before we start the testing, let's check the current sleep proxy status on the iMac. Let me run this command. This is a built-in command line tool. Comes with macOS, DNS-SD. In fact, it's not only for Bonjour, it's a general tool related to DNS-SD and MDNS. It's a service discover tool. And what I'm saying is I want to browse the sleep proxy service. Okay, as you can see, iMac knows, okay, in the network there is 1 sleep proxy, and you can see from the instance name is the Apple TV, right? The last thing I want to check is the current power management setting on the iMac. Let me run this command pmset. Let's check the current power management setting. I just want to highlight one setting. It's the WOMP. It stands for Wake on magic packet, and the value is 1, which means if this machine goes to sleep, it will wake up on magic packet. That's super important. Otherwise, this whole scenario won't work. Fortunately, this is the default setting. So we are all good. By the way, to put this machine on sleep, I cannot simply use this remote session, put it on sleep, because any movement of my mouse cursor will wake the machine up. So the way I will put it to sleep is to first close this remote session, then I will physically go to the iMac machine and put it to sleep. I will be right back. Okay, now the iMac is in sleep mode. Okay, I already launched the 2 Wireshark sessions. The upper right one is monitoring the Apple TV, and the lower right one is monitoring the iMac. As you can see, the second Wireshark is pretty quiet because the iMac is in sleep mode, right? So then in the left side Linux machine, let me try to connect to the iMac. For example, let me run SSH. You can see there are a whole bunch of WakeOnLan packets sent already. In the lower part, you can see the iMac is busy, and in the Linux, you can see it's prompt for password. So now the iMac is already waked up. Let me stop the 2 Wireshark sessions. Let's examine the captured frames, try to understand how the sleep proxy works. So let's see from Apple TV perspective what network packets it received during the process. Let's start from this one. See, the source is VMware something. It is for the Linux machine. So the destination is a MAC address, and you can see it matches what I already marked in the diagram. Is for the Apple TV, right? And the protocol is ARP. See what's in the info? So basically the Linux machine asks the Apple TV, do you know who is this IP address? Who is the iMac? The Apple TV sent out a WakeOnLan magic frame from Apple TV to the iMac. Even though now the iMac is not responding, it's in sleep mode, Apple TV acts as the sleep proxy. It received the ARP request from Linux, and then it will first wake up the iMac. That's why it sent out the WoL. The iMac was waked up, and then because the Linux was still trying to connect to iMac, the 2 machines were both active, so the communication could proceed. And from the iMac perspective, I don't want to waste your time showing you the captured frames because nothing special. Basically, the wake up process was transparent to iMac. The only thing the iMac did was to understand who is the sleep proxy and then notify the sleep proxy that, okay, here is a sleep client, and if needed, please wake me up. That's it. That's the Bonjour sleep proxy service is. So in the first scenario, the Apple TV played a very important role. Without the Apple TV, there would be no sleep proxy and no machine would send the WakeOnLan magic packet to the iMac. iMac wouldn't wake up, right? Then here comes our second scenario. What if we don't have the Apple TV? So whether the same communication is still possible when the iMac is in sleep mode? Of course, our assumption is no. So let's validate it. I have completely powered off the Apple TV from the iMac. Let me try to see whether there's any sleep proxy in the network. Okay, it's searching, nothing's found. So there's no sleep proxy now. Let me repeat the same step. Physically go to the iMac and put it to sleep mode. Then let's try to connect to it from the Linux. Okay, now from Unified Network Controller, for this port 5, you can also tell from the color, it shows the machine is in sleep mode so that the network interface card uses less power. It only has 100 megabits speed now. So now we are ready to try to connect to it from Linux. Let me run the exact same SSH command. Okay, it will wait, but you can tell from the color of Unified Network Controller for this part, it remains the same color, so the machine is not wait up. From the Linux side, it's timeout, so it report error. The connection failed. That means our testing is successful. But let's go back to the diagram, discuss something else. So this is the diagram for our previous scenario. The whole scenario worked simply because the Apple TV acts as a sleep proxy. But hold on a second. Most of the time, the Apple TV is not in use. It will also go to the low power mode. Right? If it works the same way as sleep mode for Apple TV, it also cannot react to the ARP request from the Linux. It cannot act as sleep proxy, right? Because itself is in sleep mode. That's exactly where the magic is. Because Apple TV is so efficient, Apple designed it to work in different way if we compare it to normal computer when it comes to sleep mode. Even when it's not in use, the Apple TV is still acting as the sleep proxy. It will still actively monitor the network traffic. That's the difference. That's why it's so crucial in the whole scenario. Keep this point in mind because this is closely related to our next two scenarios. Let's proceed to the third scenario. I already replaced the old iMac with a pretty new Mac Mini M2. All the other configurations are the same. So from the Mac Mini, let me run the same command to check the current sleep proxy status. The same result as previously. There is a Apple TV. It is the sleep proxy. So we are good. Then let me go to the Mac Mini and put it to sleep mode. Then we can try to wake it up. Even though now I already put the machine in sleep mode for multiple minutes, as you can see from Unified Network Controller, the connected part is still showing green color. It's not a good sign because that means we may encounter some unexpected result during our testing. But anyway, let me continue the testing. I already launched the two Wireshark sessions from the Linux client. Let me SSH into the Mac Mini. Okay, it seems the connection is successful. Let me stop the capturing. So from the Wireshark session for Apple TV, let me try to filter on WakeOnLan packet. No, nothing. Let's scroll to the top of the Mac Mini captured packet. See the very first packet that happens immediately after from the Linux. We try to connect. Mac Mini directly responded back to the Linux machine, told the Linux, okay, I am the Mac Mini you are trying to connect with. That's the ARP packet for. Okay, then all the following packets were just simple, normal packets, nothing special. So the behavior is exactly like the Mac Mini was not in sleep mode at all. From the Apple TV session, you can also see there's no effect when it comes to sleep proxy. So the Apple TV didn't play a role during the session. The Apple TV never wake up the Mac Mini. Just to make sure our observation is correct, let me go to the Mac Mini and run a command to check the real wake up reason. This is the command. Basically, I want to show the system log, and starting from last boot, I want to see the lines with the wording wake reason. Okay, you can see these two lines. They are related to our testing. Mac Mini wake up because of the Ethernet service. There was connection attempt from this MAC address, which is for our Linux virtual machine, this IP address, and to this Mac Mini itself. And you can see the port number is 22, which is for SSH. So the Mac Mini wake up not because of Apple TV. Instead, it wake up by itself because it sensed the connection attempt from the Linux machine. So this is what we observed. That's why we need to have the very last testing scenario. Let's validate whether Apple TV is really necessary at all if we simply want to wake up this new Mac Mini, whether we still need a so-called sleep proxy. Now I have completely powered off the Apple TV from the Unified Network Controller. You can also see the Apple TV is gone. By the way, from Unified Network Controller, for port 5, you can see it's connected to Mac Mini, right? Now it's showing the color for power saving mode. Now let me try to SSH into the Mac Mini to see whether we can still wake it up. Yep, no problem. So the Mac Mini made it up by itself. It doesn't really need Apple TV. You can also confirm the Mac Mini status by the color for port 5. It's green now. Okay, so we have completed all the 4 scenarios. Let's summarize what really happened. If you search internet for Bonjour sleep proxy, you will always see, okay, you need either the very old Apple AirPod or Apple TV to act as sleep proxy so that your Apple device can wake up if other devices try to connect to it. Right? Apparently those articles are not up to date because for recent Mac machines, they have already become super efficient, just like Apple TV. During the sleep mode, they already worked very similarly to Apple TV. So the network interface card actively listening to the incoming packet, and it will respond if needed. So that's why the new Mac machines can wake up without the help of the Apple TV. It doesn't really need Bonjour sleep proxy. Okay, that's the end of the video. Thanks for watching.